Okay, welcome again to this course. This is a makeup lecture for those of you that were not in the physical lectures. So this is data science introduction with Python, and I suppose you've gotten the assignment that I gave in Python, the video lectures that you're going to watch, because that is going to form the bedrock of this, especially when we enter the practical aspect of this course. Okay, so we are going to be introducing data science in this lecture. Okay, so data science overview. The question is, when we talk about data science, what do we mean? We say it is a multidisciplinary field that involves the expertise of a data scientist, a data engineer, data architect, a data science developer, and data science manager. Okay, so when you look at it, you will see indeed that it involves a lot of disciplines that are merged together to form a whole. So the whole essence of this, the course encompasses the process of extracting insights and knowledge from both structured and unstructured data. Now we have to be attentive, because if we are really studying only structured data, then several domains or several areas may be left uncovered when we want to make some business decisions. Okay, so it involves the process of deriving insight and knowledge out of both structured and unstructured data. So it combines the expertise of the different domains of study like statistics, mathematics, computer science, and several domain specific knowledge. Okay, so there are several domain specific knowledge that you will have to be conversant with, so that you'll be able to work in that domain. Okay, and so when you are working in a business environment, you will have to at least be familiar about the business that you're working on, so that you will be able to interpret the data when you see one. Okay, so the basic goal of data science is just to be able to extract valuable information that will help in making decision or making business support decisions, so as to enhance to enhance the business. So the whole essence of data science is in a cycle. Okay, so it begins with the understanding of what the business problem is, the domain where you are working. When you want to analyze an environment, you have the need to first of all have an understanding of what the business problem is, because the business problem will help you to derive your objectives, to know what you are actually targeting at. And when you know what you are actually targeting at, it will help you to know which data is important to you and which data is not important. And so in that area, you start talking about gathering the data and then preparing the data. Because of your understanding of the business problem, you now know which data you really want to look at. Okay, so you gather such data that you need at that point, and then you start the process of preparing the data. And after preparing the data, you can now start analyzing the data. And when you have finished analyzing, you now need to model the behavior of the data in order to know how the data behaves. Okay, after you finish modeling the data, modeling the data, you will have a working model, and then you need to evaluate the model using a data that has not been applied to the model before, and watch the behavior of the data and what the behavior of the model, to see whether the model is giving out good results or not. And so in that process of evaluating the model, you also will need to optimize some certain things. That is what is called a hyperparameter tuning. And then when you are done with the evaluation of the model, then you proceed to deploying the model. Okay. Now, all of these steps are the things that we are going to be looking at in the subsequent slides. So this process involves the step of defining the problem, deploying solution, ensuring that the entire process is structured, reproducible, and results in a meaningful outcome. Okay. Now, we come to the first phase, that is understanding the business problem. Now, there are the two basic questions that you need to ask in order to have a proper understanding of the business model. Number one is, what problem do you intend to solve? Okay, you have to give a clear definition of the problem that you intend to solve. Okay, you need to look at your goal, the goal, that is what you are looking out for in that. And then you need to also outline the boundaries and limitations of your project. Okay, so your project must be well defined and clearly stated. This will help you to know to enter into the next step. Okay, in the next step, you ask the question, how will you assess the data for this project? Okay, having known your area of interest, what you are focusing on, you already know which data and what data you need to collect. So the next step now is determining where and how relevant data can be obtained. So by this, you will have to either be knowledgeable in the domain or be working with a domain expert. So there are several ways that data can be gathered in this entire domain of data science. So you start gathering the data, the required data. Some of them can come through databases, application programming interfaces, web scraping. So there are several ways, depending on your business need and the goal of the data science project. You have to know which and what data needs to be collected, where and how are we going to collect this data. Okay, next thing is for you to go ahead to prepare the data. Okay, when you collect raw data, they will be characterized with noise, and so before you use such data, it has to pass through processes. Number one is the cleaning of data, and in the area of cleaning the data, there may be, maybe you are handling data that were returned through questionnaires, and then you discover that there are fields in that questionnaire that are not compulsory, or that the respondent decided not to add, maybe for security or privacy issues. Okay, so those data, we treat them as missing values, and then there are several other data that may have been misplaced, or rather they are not consistent with the data you are looking for. Okay, and then you know how to deal with such data also. And this process of preparing the data is actually the largest, or rather the most time consuming process in the data science lifecycle. Okay, now when you have cleaned the data, there are several other data points that need to be transformed. So this involves converting the data in a suitable format, or scaling the variables and handling categorical data. Okay, so there are two basic points or two basic steps that you take in preparing your data for analysis. Number one is data cleaning, and then number two is data transformation. Now, when you have finished cleaning the data, you can now perform analysis on the data. So in this process, it involves running some checks on the data frame and using the shape of the data and other measures of central tendencies to explain the characteristics or the behavior of the data. Okay, so this process involves descriptive statistics, and descriptive statistics summarizes and visualize the key features of the data. This is what you must have studied in your basic statistics: finding the mean of the data, the median, the mode, and even the standard deviation, the variance associated with the data you are working with. Now, when you have looked at the descriptive statistics, at that point you can make some inferences to discover that this is the way the data is, that this data is right skewed or is left skewed, the mean of this data is centered around so and so value, and you are going to see a lot of things there. Now, but when you are looking at the figure, it may be difficult to actually understand the figures the way they are, and so we enter into the next step of exploratory data analysis, which is visualizing the data, because charts help to quickly have a glimpse of what the data is like, or what it looks like, or what the data is communicating at every point in time. So we enter another step that is called data visualization. Now, when you have ended visualizing your data, you may have the need to create new features. And in other words, derive meaningful features from existing ones to enhance the model performance. Okay, so there are times that you may need to combine two features to form another. Okay, and then there is dimensionality reduction, which helps you to reduce the number of features while retaining important information. And this is done based on the scope of the problem you are working on. So exploratory data analysis involves descriptive statistics, data visualization, creating new features, and dimensionality reduction. Okay. Then next you proceed to modeling the data. Now, before you model the data, you have to model it alongside an algorithm. So the first step is algorithm selection. And so before you model it, you need to have a good understanding of the machine learning algorithm that is appropriate for the domain you are working on. And so some of the families involve the classification models, regression model, and clustering models. So following the selection of the model family, which I've just mentioned as classification, regression, or clustering, following them, you can now carefully select and implement the main algorithm out of that family that you want to use to model the data performance, or rather model the behavior of the data. So when you have applied the model or the algorithm upon the data, you have a model, and then that model is what is typically used to train the data. Okay, so you train the selected model using the data that you are working with, the data that you have cleaned. Now, when in the process of training, it is typical to have 70% of the data for training, and then you have maybe 20% of the data for testing, and then the 10% for validation, depending on the percentages you want. But typically, greater percentage of the data is used in training the model so that it will have enough data to stabilize the model behavior. Okay, now when you have finished training the model, you have a model that is already trained. The next step is to assess the performance of the model using validation data, the validation data that I just mentioned. Okay, in some cases you will have the testing data and the validation data. So various statistics are used to measure the performance of the model. Okay, and when you are dealing with classification models, you will have the accuracy, you will have precision, recall, log loss, and so on and so forth. And then when you are dealing with regression model, you are dealing with the mean square error, and so on and so forth. So unsupervised model, you have the round index and the mutual information. These are actually the yardsticks, the things that you will use to check the model performance. And the more acceptable model performance, there are standard acceptable model performances, that figures that you will have to make the model acceptable. And that also depends on what you're working on, whether it's a time critical, or rather whether it is a critical system or a non-critical system where you can accept some level of adjustment. Okay, now after that, when you are testing the model, it's possible that you are not getting what you are looking for the way you want it. Okay, and so this brings us to the tuning of the model, and this is called a hyperparameter tuning. Okay, then we have the cross validation. This tuning involves cross validation and hyperparameter tuning. So in cross validation, you validate the model performance of multiple subsets of the data, and this process tests the performance of the model on the data that it has not seen before. Okay, that is cross validation, to see whether this model is actually working very well. Then the next step is what is called hyperparameter tuning. At this point in time, you begin to optimize the model parameters by better generalization. Okay, this involves adjusting some parameter values in order to see if the model result could be better. Okay, so you have model selection, reviewing the parameters, selecting right searching method, applying cross validation approach, and assessing the score of the model to see if the score is acceptable according to your project focus. Okay, then when you have actually accepted the model, the next step then is to implement the model, or rather to integrate the model. Okay, so this model can be integrated directly into your application. It may be a website, it may be a model, it may be a mobile application. Okay, and so the application will begin to give a real-time result based on the performance of the model, and in that process you continue to monitor the performance of the model so as to know when there is need for you to retrain the model or to update it as needed. Okay, that's the process of the process in the data science life cycle. So next we are looking at already the types of data that you can encounter when you are running your data science project. Okay, and there are different domains and several domains where data science can be applied. You can apply it in geographical domain, cultural, scientific, financial, statistical, meteorological, natural, transport, and several areas that are not mentioned in this diagram by your right. Okay, so there are basically three types of data that you can encounter in all of these domains. Number one is a structured data. Number two is unstructured data. Number three is semi-structured data. Okay, now first we look at the structured data. Okay, structured data are data that are highly organized in such a way that we can easily query the data and get the data the way we want to see it. Example of these are the data that are arranged in relational databases. So in that relational databases, you notice that informations are stored in rows and columns. And when we talk about rows, we talk about, let me see if I can show you now. When you talk about rows, you talk about working in, when you talk about rows, you are talking about this side, and I want to believe you know it already. When you talk about column, you are talking about this side. Okay, so you see that the information is highly organized. This can be a relational database that stores student records. So in this place, you can have the name of the student, you can have the age of the student, you can have the reg number of the student. At this place, you can have the the gender of the student, and so that's student one. Then another row is going to be student two, and so on and so forth. And so that is why this is called a structured data. Okay, now you also have a comma separated values, that is called the CSV files. Okay, and in CSV file you find the same method, name comma age comma gender comma reg number comma and so on and so forth. The important thing is that that data is organized with a specific structure using commas to separate each value. And then we have tabular data that are organized in rows and columns. Now these are not databases, but they are same with the databases. And so we have Excel sheets, Excel spreadsheets in this format. So in your data science project, you can have data stored in a Excel file, and you're going to call it up and then run some checks on it. Okay, that's all about structured data. The key point about structured data is that there is a unique way that the data is organized, in such a way that when you fetch one record, you have to fetch the other record in that same way. Okay, next is unstructured data. So in unstructured data, the data lacks a predefined data model or organizational structure, so it doesn't and cannot easily fit into any traditional database. Okay, and its format is not easily analyzable by conventional data processing methods. So example of these are images, audio files, videos and text documents. So these documents are unstructured. Okay, so when you run into a problem that you are needing to analyze text documents, images, audios, videos, you should already have it at the back of your mind that, hey, I'm working with an unstructured data. Okay, next is semi-structured data. In semi-structured data, there's a pattern that the information is going. Okay, it has some level of structure but doesn't conform to the rigidity of a traditional database. So semi-structured data often includes tags, markers, or elements that provide a partial organizational framework, like you can see with JSON data, XML data, new SQL databases. Okay, so when you see something like what we have in this pane, you know you are working with semi-structured data. When you look at it, you will know, yes, there's a kind of a structure that you have here, but that structure is not consistent. The structure I have here is not really consistent with what I have here. Okay, so it's semi-structured. Okay, now we have to look at several places where we can apply data science, and that will help us to have an understanding of how important data science is in our today's work. Okay, there are several places, but we just have mentioned a few in this particular lecture. Okay, we have the healthcare. Okay, you can use data science, you can apply data to forecast disease outbreaks, and you can use data to identify high-risk patients, predicting patient outcomes, tailoring treatment based on individual patient data and genetic information. So when you have gathered the data of patients over time, study the recovery behavior responses of such patients, you'll be able to know from the data you have if this patient is resistant to a particular drug or not. Okay, or rather, when you are looking at a medical record, you'll be able to predict whether there's going to be an epidemic or whether a disease is about to be rated, or rather to be called an epidemic breaking out at every point in time. All these things are possible when we have medical records at our disposal. Okay. Another area is in the area of finance. We can use the historical financial records to be able to see what or where the economy is heading to, and you can even identify risk that is associated, risky behaviors that are associated with the economy, things that will contribute to the recovery of the economy, or things that will make for the collapse of the economy. Okay, when you have financial data, you can use it also to identify fraudulent activities. When you suddenly look at somebody's bank account and you notice a sudden irregular pattern of account withdrawal, that can raise an alarm that perhaps a fraudulent activity has hit a particular account, and then you can start running checks immediately or to raise some critical security measures to make sure that such does not happen. So what we're saying in essence is that in security of finances, in cyber security, especially as it concerns securing our financial transaction or financial records, data science is very, very important in order to trigger some measures to protect financial records. Okay, next is in retail. Can use it in understanding customer behavior so as to be able to help in creating targeted marketing strategies or to predict product demand in order to provide or rather optimize inventory management. Okay, and there are several areas that you can use data science in the area of retail. You can use it in ensuring market price balance and so on and so forth. There are things that you can use. There are several areas as data science is of utmost importance, especially in the domain of retailing. Okay, in manufacturing, excuse me, you can use data science to forecast equipment failures in order to optimize maintenance schedules. Okay, for instance, when you have some sensors attached to certain industrial machines, the sensors will be monitoring the health of the industrial machines and be reporting in real feedback, and then the system will be monitoring the health of the machine in real time and continuously working with the model that has been that has been trained to monitor the health of the machine. And so any slight deviation in the sensor feedback or information supplied or the data supplied through the sensors as it regards the model that has already been developed will detect whether there is an equipment failure about to happen. Okay, so data science is actually used in manufacturing in order to forecast equipment equipment failure. Okay, it can be used in analyzing production data, okay, to enhance product quality. In telecommunication, data science can be used to analyze the network data in order to improve service quality and optimize the infrastructural usage. Okay, it can help also to identify factors that can lead to consumer churn and implement retention strategies. Okay, in education, we can use data science is very, very important in adapting educational content based on students' performance data, analyzing data in order to enhance the institutional operations and planning. Okay, so let's take for instance you are able to analyze the performance of your students in different subjects. Okay, you can use data science to detect students that are not doing well, and a deeper dive into the exams that the students must have written will be of help in ensuring or rather detecting the several aspects of the courses or topics that are very difficult for students to understand, and then the teacher looking at the result of his already developed model will be able to check to see how best to go about handling a particular course that he has found out that perhaps most students failed. Okay, a particular topic rather. Okay, now in industries, it can also be used in marketing and advertising industry. Okay, to create personalized and effective advertisement campaign based on the customer data or the customer behavior. In energy, it can be used to optimize energy distribution. For instance, let's take for instance the electricity distribution company. When they look at the environment around, they look at when they check the data of the people around, they may want to use the information derived from their customer database to know how to share the mega power resources that they have so that everybody will have a fair share of electricity supply. Okay, it can also be used in transportation and logistics in order to optimize transportation routes for efficient and cost saving. For instance, This is embedded in a Uber or Bolt, okay, application, because that application also has the capacity to analyze the traffic movement in a city in order to actually suggest the best route that the driver might take at certain points in time using the map API built into the application. It shows you where there are congestions and then suggests several other routes that you can follow in order to avert entering into a traffic jam. So we have data science use also in government. Okay, so this is a complete overview of this data science introduction. Okay, thank you very much.